Okay, ladies and gentlemen, remember in video 1, we talked about solving a system of linear equations and testing a point to see if it was a solution. So testing a point, well first remember, a system of linear equations was simply two or more equations. Two or more equations. To test to see if a point was a solution to that system of equations, we simply plugged it in. If it made both equations true, then we said it was a solution. What I want to do now is look at, okay, what does that really mean? What does it mean when a point is a solution to a system of equations? To do that, we're going to look at the graph. So, we're going to graph the two equations from the beginning of video 1. So remember, when I graph an equation, I have multiple ways to do it. I could make a table of values for this problem, but being stellar algebra students, we know the easier way is to actually solve the equation for y. Put it in slope-intercept form. So we draw our line down the equal sign. We get that y by itself. In this one, we're going to subtract x from both sides of the equation. That will give us y equals, that kind of looks like an x. Let's get rid of that little tail. Y equals the negative x plus 7, or 7 minus x. It doesn't matter what order we write the two in. To graph that, we know our y-intercept is 7. So, the first thing we have to do is figure out, all right, what scale should I use? And I think I can get by with a scale of 1. Remember, you must label your axes so we know what scale we're using. So I'm going to put a point on the y-axis at 7. 3, 4, 5, 6, 7. The scale tells me I'm counting by ones. My slope is negative 1. As a fraction, that would be negative 1 over 1, so my rise and run. So from this point, I'm going to rise a negative 1, or down 1, and then run 1. So here is my line. If I graph that, I have my line. Okay. So there we go. Next, what I want to do is graph the second equation. So this one, getting y by itself, is not going to be quite as pretty as it was in the first one, but we're not afraid. So we're going to get this y by itself first by subtracting 2x from both sides of the equation. That gives me a negative 3y equals negative 11 minus 2x, or minus 2x minus 11. Order doesn't matter. Now, I'm going to divide both sides of the equation by negative 3 to get that y by itself. But remember, when we are dividing a number, we have to make sure we divide each term by that number. So I have to divide both the negative 2x by negative 3 and this negative 11 by negative 3. So that's going to give me y equals. Now I have a fraction, but we're not afraid of fractions. So negative 2 divided by negative 3 is really a positive 2/3 x. And the negative 11 divided by negative 3 is a positive 11/3. Now, when I go to graph 11/3, I'm going to have a ballpark of what that is. So 11 divided by 3 goes in 3 times, 9. A remainder of 2, so in other words, 2/3, because I put it up here. So 3 and 2/3. So plus 3 and 2/3. That gives me an idea of where to graph that. So it'll be somewhat of a guess in our graph, but you'll see how we handle that. So I go my y-intercept of 3 2/3. So 2/3 of the way between 3 and 4. And now from there I have to go up 2 and over 3. So up 2 moves me to here, and then over 3. Up 2 over 3. So now I can graph that. And remember what we found in that last video. That last video, we said that the point 2, 5 was a solution. The point 2, 5 was a solution. Well, look at where 2, 5 is on the graph. 2, 5. Right there. The point that makes both equations true is the point where the two lines intersect on the graph. That is called solving a system of equations. Solving a system of equations. This is important. Solving a system of equations is finding the point where the lines cross. Finding the point of intersection of the two lines. What does it mean to solve a system of linear equations? It means find the point where your two lines cross. So, the second one we had last page, or last video, was one that didn't work. We had y equals negative 2x minus 4, y equals x plus 4, and it's asked us the question, was negative 2, 0 a solution? That's what it asked. So, what did we do? We graphed our 2. Again, let's count by ones for a scale. Graphing y equals negative 2x minus 4, y-intercept negative 4, slope negative 2 over 1. So right here is the first line. Okay, that's our first line. And graphing the second one, the y equals x plus 4, y-intercept is 4, slope 1, so 1 over 1. So that's right here. Remember, we can rise 1, run 1, or we can go down. So, to graph that is right here. So the question, was negative 2, 0 a solution to this? We look, here's the point negative 2, 0. Well, the point negative 2, 0 worked in the red equation. It made this equation true. But the point negative 2, 0 is not a solution on the blue. So it's not the point where the two cross or intersect, meaning negative 2, 0 is not the solution to the system. All right, that solution appears to be about what? Negative 2 2/3, 1 1/3 maybe, who knows? We'll look in the future of how to find that exact point when it's out in the middle of nowhere. But the next video you're going to have is going to, again, we're going to solve a system using graphing. What does it mean to solve a system? It means find the point where your two lines cross.